Okay, so we'll go ahead and start. You can hand the scissors to Lucas there. Thank you. So we start on page 28 today, and scissors are going around because folks are cutting out something on page 5, so we'll use that later today. But for right now, open to page 28. And while we're doing that, we'll take a look at the calendar. And as people come in, just tell them what they're supposed to cut out. So gang, we are getting very near the end of the semester. So today we talk about cryptography. And in fact, next class we talk about cryptography. And that's it as far as new material for the semester goes. We have today and we have Thursday. The last Tuesday, Thursday class is 1 week from today. We'll figure out something to do on that day, but we're not going to add more material for a test. This week will be the end of the material for the test. And then we'll have a review day next week, and then the third test will be 2 weeks from today. So 2 weeks from today, this class will be over. And while the calendar is here, the project again, if you want a chance to do a revision, you got to hand that project to me by 1 week from today. Okay, so projects due 1 week from today. If you want to revise, if you're not worried about revising or you just can't get it done, you can hand it to me 2 weeks from today on the day of the final. Any questions on the dates? Okay, then let's come back here to page 28, and we'll start with Kristen, number 1 at the top.
One section and the next discuss materials has been adopted with permission from James.
Thank you. Stephanie, number 2. Okay, anything you guys have sent recently that you hope is secure? Online what? Online banking? Email? ATMs? Good. Do you want your texts to be public or private? Okay, so presumably we want them to be secret as well. Lots of places that we hope information is sent securely. So that's what we talk about today. So we'll go to Mike for number 3.
It is largely impossible to prevent this. So it's to try to disguise this process is called.
Okay, thank you. Morgan, number 4. Keep going. Okay, so we got 2 different directions. We want to be able to encrypt a message, make it look like gobbledygook, but we also want to make sure that somebody is able to decrypt the message. That's going backwards, taking the gobbledygook and getting the original message out of it. Okay, we'll keep going here with Alex, a cipher. Okay, so we need to make sure that we come up with rules to make our messages look like gobbledygook, but the rules have to be reversible. They have to be able to be undone. Suppose that I came up with the following shortcut. So the message that we are going to encode is this one. The word is going to be issue, and we're going to encrypt it and make it look like gobbledygook, okay? So here's my rule for encrypting that word. We're going to take every letter and replace it with the letter A, okay? So the first thing becomes A. All right, so I becomes A. How about S? S also becomes A, and so does that one, and so does that one, and so does that one. This message has been encrypted, yes? Okay. Is it reversible? Can you recover the original message from that? No. This was not a good way to encrypt the message. There's not enough information in here to be able to figure out what it started as, okay? And so that's this idea of reversible. You can't just make up any old rule. You have to make up a rule that can be undone. This was not a good rule. All right, we'll go down to number 5. Where are we now? Okay, thank you. We'll go to Lucas for 6. Haley? Okay, that right there is the first cipher that I'm going to want you guys to understand. Remember, cipher is just a rule that tells you how to encode a message, how to encrypt a message. So the Caesar cipher is exactly what Haley has read, is that you take each letter and you replace it by the letter that's 3 places later in the alphabet, okay? That is the Caesar cipher. So if on a test I talk about the Caesar cipher, it is your job to know the magic number for Caesar is 3. It is always 3 later for the Caesar cipher. Could we do 4 later? Sure. It's just not called the Caesar cipher anymore, all right? So A becomes D because starting at A, you go A, B, C, D is the 3rd letter afterwards, right? B becomes E. What do we do at the end of the alphabet when we get W going to Z? We're just going to wrap back around, okay? So X goes to A and Y goes to B and Z goes to C. So you guys have those 2 things that you cut out in front of you. This will be the first time we're going to use them. So what you want to do is line it up so that the A in one of them is next to the D in the other. I always forget which one I'm supposed to use, so match up the A with the D and see how it looks. A goes with D. Does everybody have it matched up? So we're going to get you a pair of scissors. Where's an extra pair of scissors? Mike, could you bring those up here for us? Thank you. So on page 5, you're going to cut out the 2 alphabet things. So the people that have it already cut out, we have A matching with D. And then right next to that, you should see B matching with E, etc. Okay? So people that have already cut it out, so you're going to cut out those 2 long boxes. You're going to have 2 pieces of paper. So for everybody that's got it cut out, are we matched up? Okay. So let's go to number 7. 7 will go to Tim. Okay, thank you. We're going to skip down to number 9 for Kristen again.
When you're ready with your attack at daybreak. Did you get it? Write your answer.
Okay, so we're just going to do the first couple of letters here, and then you guys will go the rest of the message. So attack at daybreak. The first A becomes what letter? Becomes a D. I've got that up on my page. I'm just going to write them all capital. All right, now I don't have T on my page, but you guys should be able to look at your little slider things, find the T, and what letter does T become? T becomes W. Any questions on that one? How about the next T? Also becomes a W, and you're just going to write one long word. You're not going to space it according to the words attack at daybreak. You're just going to write one long string of letters and then check in with your neighbors, like fill in that 4th one and just double check that everybody at the table has the same one, and then see if you can do the rest of the message. Okay, so I've got Kristen's answers up here. Can you guys double check? Do we agree with this? Any questions on this? Morgan, which one do you disagree with? At the end, you have UHN. All right, Morgan has that. What do you guys have? Kristen, what do you have? Do you have the first one or the second one? Oh. So this should be a U right here? Okay. What about this H? There? Is the D right? Okay, I've got 1 thumbs up. Do folks have this or something different? Okay. Let's go. All right, so one of the things that you guys are recognizing now is that you got to be really, really detail oriented to get this right, because there's not a lot of information in there that's going to tell us we made a mistake, right? It's supposed to look like gobbledygook, so you're not going to recognize if it's the wrong gobbledygook. So be really careful, really detail oriented. Let's go to Stephanie for 10. Okay, so we're going to ignore the spaces from the attack at daybreak. Don't worry about those spaces. We want to just do every 4 a space. So rewrite that stuff right there. And after every 4th letter, make a space. Just makes it a little bit easier to read. There's nothing special about 4. We could have done 5 or something. Yeah, so then if you didn't have an even number of 4, like if this was an XY at the end, you just have 2 letters at the end, and that's okay. And I know it's very unnatural to ignore the spaces. You know, attack at daybreak feels like we should be writing 3 words, but those spaces give information, don't they? Like if we had it just word for word with the spaces in the right spots, then people would know, oh, there's a 2-letter word in the middle. There's not all that many 2-letter words in the English language. We could just try them all and see if we can figure out what that one is, right? So you don't want to give the information of the spaces. It's very unnatural for us to ignore spaces like that, but it's better to ignore the spaces. So when you're ready, we'll go to the next page. Mike? Okay, so we're just going the other direction. It used to be A becomes D. Now D is going to go back to A. Doesn't make any difference to me how you line the things up, but just make sure you're going in the backwards direction.
It's in 4 blocks. Do we try to make sense of what it's saying?
You're going to make sense of what it says after you get the real letters. So don't worry about those spaces. So what does this D become? D becomes A. What does O become? L. O becomes L. We're going 3 before. So we go N, M, L, okay? So if you get A and L, then you're doing the right thing. Keep going and check with your neighbors. All right, so the message doesn't make sense with the spaces that are in the encoded version up there, but we can rearrange it. We can pull it out now that we see what the letters are. So what's the secret message here? All work and no play, okay? Okay. So let's go on to number 12. We're back to Morgan. Okay, so substitution cipher. I'm going to underline the 3 O's in the original message here. What did the first O become? L. What did the second O become? L. And what did the last O become? L. That is indicative of a substitution cipher where every time you see an O, it is always substituted for an L. There are going to be other systems that we're going to see momentarily where you don't get the same letter getting substituted for O each time you see it. All right? So this is a substitution cipher, which means every letter always becomes the same letter. Okay, let's go to 13. We're back to Alex. Okay, Greg? Okay, so look at that chart. You see the letters at the bottom and the relative frequency on the left-hand side. So what that means is, for example, you guys see this right here. That 0.08 is a percentage. Out of all the words in the English language, the letter A is representing 8% of the letters in those words. Like if you just look at a piece of paper with lots of writing on it and you counted all the A's, it would probably be about 8% of all the letters would be A's. Okay, that's the 0.08. So what are the three most common letters in the English language? We have the E, we have the T, and also A is just a little bit higher than the O. It's very close. So the three most common letters in the English language are E, A, and T. And so if you have a long message, for example, a couple of pages, you don't have to go here right now, but for example, here is a very long message. You can see lots of gobbledygook. But what you could do is, if you had a little bit of time, you could just count how many times do you see each of these letters here. I've done that for you. There's a little website that will count it for you. So take a look at this list. Which letter appears most often? H and also I. Okay, so H and I. And then what's the next one? There's Y down here is at 12. Next one is P. Okay, without knowing what this message is, and honestly I don't know it, I forgot what it is. Without knowing what that message is, there is a very good chance that the letter H is either an E, an A, or a T. Because in just about everything you write, the most common letters you're going to write are E, A, and T. And that's a real big weakness because I could just say, okay, let's suppose that H is the letter T and change all these things into T's. And then I could say, well, what if I is the letter E and change all the I's to E's? Now, if I've made a mistake, there's a good chance that I'm going to get two letters next to each other that don't possibly make any sense. Like if you had a T and then an L, you'd say, okay, that can't, there's no word that says that has a T and then an L, right? So you can trial and error your way and gradually piece out what this message is. So this is called the cryptoquote. You might have seen it in the newspaper. So it's easy to encode, but it's also easy to decode, and that's no good for us. All right, let's go down to 15. Where are we now? We'll go to Haley. Okay, so 16 talks about, and I'm not sure if I have the pronunciation right. I should have started off by saying I've never taught this before, so I hope it's good. I don't know. I think it's good, but this is the first time for me. So I don't know how to say everything, but I'm going to call that a bifid cipher. I don't know if that's right. And it uses a device called a Polybius square. I also don't know if I'm saying that word right. So here's the idea. We're going to fill the alphabet into this first grid. Now, how many boxes are in this 5x5 grid? 25. How many letters are there? 26. We're going to ignore the letter J. It's one of the least commonly used letters, and we're just going to skip over it. So let's fill in this table. A, B, C, D, E, F. So just fill it all the way in, but completely skip over the letter J. You're going to ignore it. I don't know. Well, maybe we could actually look up here. Yeah, take a look at this chart. So Z is that tiny one there at the end? Yeah, they're both not used very much. I agree with you, Lucas. It looks like in this chart. Z is, yeah, fulfilling when you get to the Z, right? So the like climactic moment. All right, Z. I don't know. And like if your favorite artist is Jay-Z, then you're out of luck, right? Both letters are bad. So, all right. So, okay, so that's what we do, and we're just, convention says we're going to skip over the J, and if you get to the Z at the end, it probably means you did it right. Okay, so let's go down to 18, and we'll go to Tim.
Instead, we'll create a keyword-based keyword function. Start by filling the letters across the row. Let's use keyword fill the letters with keyword going across the rows, but skipping another.
Okay, so don't do it alphabetically, but spell out the word confidential. but you never want to repeat a letter. So I've written the first 7 letters of the word confidential. What's the next letter? N. You never repeat a letter. So we skip N. What's the next letter in confidential? T. I haven't written T yet, so I put that. Keep going in confidential. What's the next letter? Let's see. It is going to be, what's the next letter in the word? Is I. Should I put an I? No, I've already written an I up above. What's next? A. Have I done that yet? No, we'll put an A. Last letter? L. Put that. So this is another very detail-oriented process. It's not hard to do, but it's really easy to make a mistake if you're not paying attention. Right? So just spell the word out, skip over any duplicates. Now, we're going to fill in the rest of the square. And we're going to fill it in alphabetically, just like we did before. A, B, C, D, E, F, G, blah, blah, blah. But we've already written some of these letters, and we're never going to write a duplicate letter in this square. So the first letter in the alphabet is A. Have I already written an A? Yes, I don't start at A. The next letter in the alphabet is B. Have I written a B? No. We put a B. Very carefully go through the rest of the alphabet. Don't forget, you skip the letter J. And if you do this right, the last letter you should fill in is a Z. If you get to the end and it's not a Z, you made a mistake somewhere. Always skip J. So very carefully fill it in. You should end with a Z in that last square. Any questions on that? Everybody got the Z at the end? For anybody that made a mistake, can you share with us so we can learn from this mistake? What mistake did people make if they made one? Haley. Okay, Haley put an O. Why should we not do that? We've already seen an O. Any other mistakes that people made? Mike wrote another C, even though we'd gotten the C before. Yep, other mistakes? Did anybody write a J? Yep, it's very easy to write a J. You're doing the alphabet. You've been doing the alphabet for like decades. J has its natural place. We're going to skip over it. It's very unnatural. Okay, so we filled in the alphabet. Now, what does this have to do with all the encryption that we've been talking about? So that's what's coming. But this is the start of an encryption process that we're about to do on the next page. So let's go to the next page. And first, I just want to point out that that chart right there is copied from what you guys just filled in, okay? It's got the word confidential, and then it's got the rest of the alphabet. So you've already made that chart. I just put it here so we wouldn't have to make it again. Yeah, I'm sorry it printed out so dark. The word is retreat. So maybe write the word retreat right above. And the last letter is an X at the end. We'll talk about that. But just write retreat right up at the top and then stick an X at the end. Okay. So we are going to talk about encoding using a bifid cipher. Now we've already talked about the Caesar cipher. How many letters ahead do we go? 3 ahead. And if we're decrypting the Caesar cipher, how many letters backwards do we go? 3. Just got to make sure you know which direction you're going. This process to encode using this idea of the bifid cipher is much more complex than go 3 ahead or go 3 backwards, okay? So just be prepared. We're going to encode the message to the word retreat with an X at the end. It's a lot more involved than just go 3 ahead or go 3 backwards. So be patient with yourself. This is a long process. Step A, create a Polybius square using a keyword. What was our keyword? Retreat is the message we're going to encode, but the keyword was confidential. That was what we put inside of the square. And we could have picked a different word over there, right? So the keyword was confidential. Part B, we're going to look up each letter of our message. We're going to do this in this chart. So find the letter R inside of that square. And what you're going to do is fill in the row number and the column number. So in what row and column is R? 4 and 3. So you're going to write a 4 and a 3. Always row and then column. Row on top, column on the bottom. Fill in the rest of this chart. Check with your neighbor as soon as you fill in the E, just to make sure everybody's on the same page. All right, so we look up row and column of every letter, we write it down. Next step. So we just did part B. Oh, by the way, we haven't talked about this X. It turns out, we'll get somebody to read 20 here. Can we go to Gina for 20? Mm-hmm. That's where the X came from, okay? This needs an even number of letters to work, so we just stick a letter on at the end. Doesn't matter which letter. So that was the X. So what we've done is we've looked up each letter. Part C says group the numbers in pairs reading across from left to right. So what I'm going to do is circle these guys. 4 with 2, 2 with 4, 2 with 2. Just go ahead and circle all the pairs in both rows. And now I'm going to rewrite those pairs. I'm going to rewrite them so that they're vertical. I've circled 4 and 2 horizontally. I'm going to rewrite it so 4 and 2 is vertical. Next thing I circled horizontally going across the top row is 2, 4. You write that vertically, 2, 4. Everybody see it? So write all the pairs vertically. When you get to the end, just go to the second row. And once we've got our 8 pairs written this way, it always is row and then column. So what you now do is use that square one more time, and we're going to read off the row and column and put a letter. So look for row 4, column 2. What letter do you see in row 4, column 2? Is it Q? Q is the first letter in our encoded message. 4 and then 2 is the Q. So go through and write down the other 7 letters. Check with your neighbors. Okay, so double check. Q-A-E-L-G-H-A-H. That is our encoded message. What does it still mean? It means retreat, right? It means retreat with an X at the end. So first of all, let's say that this is quite a bit more complicated than the Caesar cipher. Let's also ask ourselves if this is a substitution cipher. Take a look. Were there any duplicate letters in the original word retreat? Yes, there's an R, and then the 4th letter is also an R. So take a look down here. What's the first letter, which is an R? Q. What's the 4th letter? L. Did every R get replaced by the same thing? No. The first R became a Q. The next R became an L. This is not a substitution cipher, which means that people can't use that frequency analysis and say, oh, whatever letters are appear most often are probably E and A and T in some order. Are there any other duplicates in our original word here? E. What's the first E becoming? And what's the next E becoming? G. How would you know? Right? I mean, there's no way to look at that and say, oh, every E is going to become blah, because the E's become different things depending on where they are. So it's a lot more involved, but it's also a lot tougher to decode this thing because it's not a substitution cipher. Any questions on this? Okay. So we go to 22. Well, 22 talks about reversing the process. We're going to go here to 23. And where's our reader now? Is it Lucas? You can skip that. Okay, so it's gobbledygook, right? There's no way to just look at that and know what that thing says. So the first thing we do is we're going to fill in this chart. The keyword is Schwarzenegger, so very carefully fill in the letters of his name, one at a time. Make sure you don't ever duplicate a letter. So we're going to fill the rest of the table alphabetically. Again, never writing a letter that we've already written. So first, can somebody check me? Does the last G end up at the end of the second row? Yeah. Okay, and then we're going to fill in the rest of the alphabet, A, B, C, D, E, in alphabetical order, except never duplicate a letter. First thing I should write is A, but I've already written an A. So the next one is a B. After that is a C, but C is already up in his name, okay? So fill in everything. I know normally we said we were going to end with what letter in the bottom right? Normally it's a Z. Is it going to be a Z down there for this one? Yes, always drop the J. Will the last letter down here in the bottom right be a Z? Should I expect a Z down there? Why no? There's already one, right? Z is in his name, so Y should be the last thing you get down there. That's how you'll know if you did it right. Yes, Haley.
What if the word has J?
Then you're going to replace it with something. You can change it to an I, and hopefully the message won't get too garbled. Well, that's okay. I mean, like, so if you had a, if you, excuse me. So if you had a message and you translated it this way, sorry. Like, would you understand what that meant, knowing that some of the I's might be J's? Yeah, with a little bit of work, you can recognize it as Jack and Jill, right? So even if there's I's and J's, we'll just change the J's to I's. Okay, so very carefully, we're doing the alphabet thing. We should end with a Y on this one instead of the Z because Z is in Schwarzenegger. Any questions on filling that in? So there's lots of ways to go wrong. It's an easy process. All we're doing is alphabetical order, but never rewrite a letter and never write the letter J. There's a lot of ways to go wrong on this. So be very careful as you fill this in. Okay, and now we are going to decode. We're going to decode this Sawa, whatever it says. Any questions on the square? Alex, is it okay?
Yeah.
Okay. And when you put a W at the end, what letter did you fill in for the last one in the square? And then X, and then you didn't have a spot for the Y. Yeah. So if you don't get to fill in the whole alphabet, you know you've made a mistake. Just go back up and very carefully do the alphabet again and look out for duplications. Okay, so I really have to pause and think about this. So let's think about what we did up here. We had the word retreat. Then we looked everything up, row and column. Yes? Then we regrouped them. Instead of thinking of row and column going vertical, like one grouping of a 4-2, 4-3 vertical, we went across. We grouped them this way, 4-2, 2-4, 2-2, 2-5, etc. And then we wrote those things that are circled in green vertically. And then we finally went to the encoded message. Now we're going the other direction. So let's be really careful as we think about this. You have some gobbledygook message. The first thing we're going to do is look things up in the chart, right? We're going to write row and column in the ordinary way. So let's do that down here. So I'm going to write my message up above just so I have it. In fact, I don't really need to group them anymore. So just rewrite this message up here and give yourself a little bit of space. Okay, and then we're going to look every letter up one at a time. We'll do the first two together. Where do you see the letter S? 1, 1. So we write row 1, column 1. How about the letter A? always say the row first. 1, 5. So we write row 1, column 5. Everybody see it? So very carefully and check with your neighbors on each of these guys, because any mistake that you make is going to mess up the final message at the end. So look up every letter and fill in the rest of this table. I think it's at this point in the decoding process, the decrypting process, that things get a little bit tricky. So it's pretty straightforward. It just takes a little time to fill it in, looking up every letter. Now what we're going to do is think about what we did up above. So we're now at this point right here. We've already translated all of the letters, the gobbledygook, into the row and column. So that's what we have at this moment, is the row and column. And now somehow we're supposed to get up to something in here. So here's the idea. This 4 and 2, how does it translate up into the next table? Sideways. This 4 and 2 that's from the row column, this vertical 4 and 2, becomes this horizontal 4 and 2. Do we see it? Okay. So then every vertical here is going to become something horizontal. So this is going to take some space. So make sure you have some space. I'm going to write this so that it's a little below my table there. So the first thing I'm going to do is I'm going to group these guys. First thing I see here is 1, 1, and then 1, 5. And those things become horizontal. 1, 1, 1, 5. Do we see it? Every column becomes horizontal. The next column, circle them this way too. The next column is a 1, 4. So how do I write that here? I write that as a row, 1, 4. Do we see it? Every column goes horizontal. So you're just going to make one long row of numbers, okay? So just very carefully take every column, put it horizontal. Okay, so let's come back together and see if we can finish. We're almost done with this one. I always have to remind myself of what I did in the encoding direction, the encrypting direction. So take a look. We now have a long string of numbers, like the horizontal circled numbers in this chart. Yes? So that's where we are. And all we need to do is recognize that. Here, take a look at all of these numbers right here. Well, they were already written for us very nicely in the second row, but in the example that we just did, we continued the string up here, right? You guys have one long string of numbers, but I really want a row and another row, yes? So what are you going to do? You're going to take half of the numbers that are out here, and you're just going to put them underneath.
Always half.
Always half, which is why we need an even number of letters to start with. So what we're going to do is come down here. You have a long string of numbers all horizontally. I ran out of space a little bit. We're going to cut that string in half. So we just have to find the halfway point of this string. Halfway point in this case is 16. I think Melissa had said there were 16 letters to start. So we're just going to go right in half. 2, 4, I'll do this here. So it's 2, 4, 6, 8, 10, 12, 14, 16. I think for me, the 16th digit is that 5 right there. And then I'll double check that I have another 16 after. 2, 4, 6, 8, 10, 12, 14, 16. Good. That 5 is the 16th number, which means everything after that 5 is about to just get picked up and copied and shoved underneath this one. Line it up so that every digit is underneath one of the first 16 digits. So I'm going to take this 3, 5, and I'm going to put it right under here. So it becomes 3, 5. You see it? And what's the next thing that I'm going to write under here? Is 1, 1. So just grab those last 16 and put them under the first 16. Got to line everything up. Did I make a mistake? Under the 14, that 14? Switch. 1, 1, 5, 1. 1, 1, 5, 1, 5, 3. Well, I've copied down what I had. I might have had the wrong thing. Okay, so I actually did this beforehand just in case. 515341. 511514. I think this is right.
Just like the extra letter.
No, there shouldn't be an extra letter here. This one is even, and that's fine. So, okay, there's a lot of details here, gang. The process is, it's not that hard. None of the steps are hard, but a lot of steps involve much attention to detail. Okay, the final step here is really easy. So once we've got the two different rows separated, it's going to be easy. Now, I'd encourage you to not give away the ball game. If you see what the message is as you're writing it down, don't just shout it out loud because that takes away the fun from other people who aren't there yet. But again, it's row and column. So I'm going to write the words row and column right next to these guys. And so we're going to take that same Polybius square, just don't say it out loud, and we're going to write out row and column. So the first number, 1, 3. First row, third column. What letter is in 1, 3? H. Everybody see it? First row, third column, H. So very carefully, and don't give it away when you see it, write out what this message really is. So as you fill in the Polybius square for the word secret, again, you should get the letter Z as the last letter you write down.
We can work this out.
Codes are fun is the message we're going to encode, but the, what is it called? The keyword is secret. You can rip that out. Tim is pointing out that codes are fun doesn't have the right number of letters. For this to work, it's got to be an even number of letters. Remember how we took the second half of the message and shoved it underneath the first half? It's got to be divisible by 2. So how many letters are there here? Let's see, 8, 3, I count 11. 11 letters is no good. We need it to be even. I'm always going to tack on an X. You can pick a different letter. Yeah, this is fine here. So the X gets tacked onto the secret message. The keyword was secret, and that's the only thing that matters in the square. All right, so let's make sure we're clear on the process, because sometimes we circle horizontally and make vertical. Other times it was vertical, we make it horizontal. You got to be really clear. Which one you're doing depends on which direction you're going. If you're encoding a message, which is what we're doing here, then you write them out rows and columns normal, and then you repair them in the other way. If I were to just pair it, like I don't want to pair this way, because that's a row and a column already. In this direction, we pair them horizontally and we make them vertical. And that's going to be something you're going to want to write down on your study sheet when you're preparing for our last test. Is for bifid, there's 2 directions, and the processes, they're opposite, but you got to know which one you're going to do. So when we're encoding a message, you write row and column just normal, and then you regroup them horizontally and make them vertical. That's this direction. The other direction is the opposite. And when I was yesterday, when I was preparing for today, I went and I did the Schwarzenegger thing just to make sure I was still remembering how to do it, and I went the wrong direction. I made rows columns instead of columns. I just went the wrong way. So still, it's tricky for me. So lots and lots of practice. I need more myself. Okay, so again, once you finish, you can check. I've got my answers up here in red. Check with your neighbors, check with me. There's a real good chance that I make a mistake when I do this too. And then try number 4 when you're finished with number 3.